So in the previous video, I'm hoping that you understood, or kind of got the idea of what radians are, where they come from, and why they're valuable. In the second video, I want to talk about, so now how do we convert between them? I mean, you guys have spent a few years working with degrees, you're used to degrees, how are we supposed to shift into radians? As far as I'm concerned, there are sort of three methods that we'll use for that, and you'll use them in different places. Like, none of these is really superior to the others, they're all just kind of different. The first is there's a formula that you can use to do exact conversion. Of course, it works for everything. The issue is that it takes a while. So after that is memorization of key values. There's going to be some angles that we work with a lot, and you knowing the exact conversion between those is a really valuable thing. And the last one is just the idea of estimation. Sometimes we don't need to know what the exact value of something is. For instance, if I said, hey, what does a 71-degree angle look like? I don't think any of you is rushing out to find your protractor so you can draw a 71-degree angle. You're going like, okay, look, it's a little bit less than 90 degrees, it's a little bit more than 60 degrees. It's, mentally you're thinking about how big the thing is, okay? So I'm going to go through these three methods briefly in this video. So the first is this formula conversion. And the idea is, because a whole circle can be represented by 360 degrees or 2 pi radians, we can convert between them by sort of using a conversion factor. We can either use 2 pi over 360 if you're going from degrees to radians, or 360 divided by 2 pi if you're going from radians to degrees. By the way, both of those fractions can be reduced. You could do pi over 180 instead. In fact, that's generally my preference. And, for this one, you can do 180 over pi. Right? So my first example here, suppose they want you to express 100 degrees in radians. So you've got the idea of 100 degrees. Now we need to multiply by a conversion factor. And a lot of people get bogged down and they forget, like, oh no, which one am I supposed to use in which instance? The hint that I give to people is, especially if you guys have done chemistry before, if you've done anything with unit conversion, you can sort of imagine, like, if this is degrees, I need to pick the one that has degrees on the bottom. I need to pick pi over 180 degrees, so that in some sense the degrees can cancel out, and I'll be left with just radians. Right? So when I multiply this out, I'm going to end up with 100 over 180 pi. The zeros will cancel. You get 10 over 18 pi. We can simplify that down to 5/9 pi. If we wanted to, we could get out a calculator and actually multiply that. We get 5/9 times pi. And we find out that angle is the same as 1.745 radians. Either one of those answers is fine. Although you're going to find in this class, as we do a lot of things with radians, lots of times we just leave pi in it. And part of the reason is it gives us an expression of, like, a fraction. This 100 degrees, if you think about it, it's almost like us saying, well, I know a whole circle is 360 degrees. 100 of those degrees would look like that much of it, right? When you think about pi, you think of it as, well, here's an entire circle. That's, this whole circle is 2 pi. So 1 pi would be halfway around the thing. 5/9 pi would be 5/9 of the way around that. And you'll notice that this concept of 5/9 pi matches with this idea of 100 degrees up here. That's where it comes from. Okay. Next up, converting from 1.4 radians into degrees. I think you guys should be able to do this on your own. Pause the video. You'll probably want a calculator for it. But make this conversion. So we have 1.4. This time I'm going to multiply by 180 divided by pi, because I want the radianness of this to cancel with the radianness of this. Now again, this one is not one that I'm going to have us do by hand, but if we multiply 1.4 by 180 and then divide by pi, we'll end up with this being 80.214 degrees. There it is. So if you ever need to know what the exact conversion between angles are, you can use these angle conversion formulas. These do show up occasionally on the IB exam. It's good to know them, but realistically you're not going to use these in a calculus setting, largely because when you get angles in calculus, they're already going to be in radians. So the next thing for us to look at is actually memorizing some of the key values. I'm going to cover a lot of this later. Within the next couple days, you guys are going to have to memorize, I think, 16 different angular values. Right now I'm going to give you 5 angle values that I expect you to know. And what I'm going to do is I'm effectively going to set up a chart. I want us to look at a degree measurement Then I want us to look at a radian measurement in terms of pi, and then that same radian measurement, but this time in terms of it like a pure number that might make more sense to you. So the 5 angular values that I want us to know about are 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. And those choices should not be surprising. If you remember what you did in geometry, I guarantee you I can bring back memories right now when I say 30, 60, 90, and 45, 45, 90. The reality is 45 degrees, 30 degrees, 60 degrees are all very, very common measurements, and they're nice measurements. Their trig is very, very, very pretty, and so it's not surprising that we use them. So let's look at the radian versions of these things. The radian version of 0 degrees, well, a 0 degree angle means you haven't gone around the unit circle at all, which means the radian measurement for that is 0. And, I mean, I guess you could put 0 pi. I'm not even going to write that 0. And so the real number value of that is still 0. No surprise. 30 degrees. Okay. 30 degrees, and if you want to understand where this comes from, 30 degrees is 1/12 of a way around a circle. Well, if you took 1/12 of 360 degrees, you'd get 30 degrees. If you took 1/12 of 2 pi, you would end up with pi over 6. So sometime soon you need to have memorized the idea that 30 degrees is the same thing as pi over 6 radians. Now, that's great to have memorized, but I feel like I want one step more than that. A lot of times when people see pi over 6, they're like, oh, it's pi over 6. You're going to get used to seeing pi over 6. Pi over 6 is going to become a good friend of yours. But pi over 6 doesn't mean much to most people. I kind of want you to have pi over 6 and to sort of understand, hey, if I were to plug pi over 6 into a calculator, pi over 6 would be pi over 6. It would be 0.524. To be honest, I don't expect you to memorize 0.524, but I do expect you to have the idea that pi is like close to 3. 3 divided by 6 is like close to a half. So I'm not at all saying that 30 degrees is 0.5 radians, but I'm saying 30 degrees is pi over 6, which is close to 0.5 radians. Okay? The others of these I'm not going to take as long to do. 45 degrees is the same as pi over 4. Pi over 4, if you actually divide it on a calculator, ends up being 0.785. But again, in my opinion, like for our conceptual understanding, if we think of pi as being about 3 divided by 4, it makes sense that that angle would be about 0.75. Okay? 60 degrees. Well, now this is interesting. 60 degrees is actually twice 30 degrees, so it makes sense that the radians would be twice that. This is going to be 2 pi over 6, which is pi over 3. And pi over 3, again, we can divide it on the calculator. We could divide pi over 3 and get 1.047. But pi is about 3, 3 is about 3. This is going to end up being approximately 1 radian. Okay. The last one of these things is 90 degrees. 90 degrees is the same as pi over 2. And pi over 2, when you divide it out is, oops, wrong color, 1.57. Again, about 1.5. So these values here, realistically, are something that I want you to have memorized by the next time class meets. There's not very many of them. Get them memorized. It will pay great, great dividends later, so make sure you memorize them. The last part of this video I hope to keep short is this idea of estimating. Like if you want to change an angle from degrees into radians, sometimes it helps just to have a gross idea of where the thing is. And I say here using the unit circle as a guide. So it's sort of like, imagine here you have your unit circle. And if this is sort of where every angle begins, it's sort of like, alright, this is 0 degrees. This up here is definitely 90 degrees. This guy here in the middle is 45 degrees. This one here is 30 degrees. This one here is 60 degrees. And I hope you guys all see where you're coming from. The idea is that 45 is 45. This is 30. This is 60. When I put a single angle up here and say 90, all of these things are with reference to a base angle down here. Okay. Now on the previous page, we just learned some values for these things. We just learned that 30 degrees is the same as pi over 6, which is about 0.5. We learned that 45 degrees is pi over 4, which is about 0.75. We just learned that 60 degrees is pi over 3, which is about 1 radian. And we learned that 90 degrees is pi over 2, which is, about 1.5 radians. And so if someone were to ask you, like, hey, I'd really like you to draw an angle that is 1.2 radians. On the one hand, you could get out your calculator, you could do a little conversion and figure it out. Or you could stop for a second and say, wait a minute, I know that 60 degrees is 1 radian. I know 90 degrees is 1.5 radians. So 1.2 radians is somewhere between 60 and 90. A little bit closer to 60 than it is. So maybe, I don't know, like 72 degrees or so. I mean, like, we can choose it, and we don't need to be perfect. The idea is 1.2 radians. Even based on that, we have an idea. That angle is about this big. It's bigger than 60 degrees. It's smaller than 90 degrees. We can see that 1.2 radians is going to be about that big. Okay? This video is a little bit on the long side, but I really wanted to make sure we talked a little bit about how you switch between these angles.